Okay, so basically, this topic deals with how to cut the objects. But how to cut the objects means what? Are we going to do cutting? What kind of cutting? Then this kind of questions arises, isn't it? So थोड़ा सा इंटरेस्टिंग होने वाला है, देखो मजा आएगा मुझे जहां तक लगता है, क्योंकि मैं जैसा पढ़ाता हूँ वैसे मेरे को मजा आता है। तो अगर कोई भी अपन ऑब्जेक्ट ले, फर्स्ट ऑफ ऑल ऑब्जेक्ट ऑब्जेक्ट मतलब मैटर है ना, द अरेंजमेंट ऑफ मैटर क्रिएट्स डिफरेंट डिफरेंट काइंड्स ऑफ ऑब्जेक्ट, इजंट इट? तो आज हम उन्हीं ऑब्जेक्ट्स के बारे में बात करेंगे। अगर बेसिकली सोचा जाए तो अपने पास इन होल यूनिवर्स कुछ गिने चुने ही काइंड ऑफ सिमेट्रिकल मैटर्स हैं। कैसे मैटर्स हैं? हम बेसिकली हम ये जो कटिंग और ये सब जो चीज है वो हम किस तरह के मैटर के लिए करने वाले हैं, किस तरह के ऑब्जेक्ट्स के लिए जो सिमेट्रिकल इन नेचर है। कैसा नेचर है उन सबका? Yeah, so basically we are going to deal in the depth of which kind of objects, symmetrical objects. Yeah, not unsymmetrical. Okay. Okay, so let us pick up some points. Let us pick up some objects. So then, like, we can create any kind of object, or you can say the object is created by arrangement of particles, isn't it? Now the question arises, we can arrange in many ways the particles, isn't it? But the basic configurations are what? Like, let's suppose I pick up a one particle, the second particle in the same direction, third particle in same direction, fourth particle in same direction. You can see that the contact between these two particles are only one. How many are there? One. Basically, one point means with other particle there is only one contact, isn't it? One point of contact. But if we look into the other particles, they have basically how many points of contact? 2 points of contact. Okay. Now, basically, if I go on arranging these particles like infinite till infinite distance, I'll get something like something कुछ इस तरह का एक straight wire है, straight rod बनते हुए दिखाई पड़ेगा या नहीं दिखाई पड़ेगा? तो ये एक जनरेशन ऑफ ऑब्जेक्ट हुआ या नहीं हुआ? हुआ है। तो basically this kind of objects, when we arrange the particles in only one direction such that we get a objects, यहाँ से जो ऑब्जेक्ट मिलेगा वो क्या मतलब मेरे को रेक्टेंगुलर सीट मिलेगा या फिर अपने को एक स्ट्रेट रॉड बनता हुआ दिखाई पड़ेगा? तो basically when we arrange the particle in only one direction such that the point of contact are limited to only one for each particle, then we will consider it as one dimensional object। इस तरह के ऑब्जेक्ट्स को क्या बोलते हैं? ठीक। इसका दूसरा नाम है लीनियर ऑब्जेक्ट्स। क्या नाम है? इज दैट क्लियर? दूसरी बार सोचो कि मान लो अगर अपन ने पार्टिकल्स को पकड़ा, अब पार्टिकल पहले एक वन डायरेक्शन वन डायमेंशन की ओर अरेंज हो रहे थे, अब मैंने पार्टिकल्स को क्या किया? छेड़छाड़ किया। जैसे ही पार्टिकल एक रख रहा हूँ उसके अगल बगल दूसरे भी पार्टिकल को रख दे रहा हूँ, है ना? बट ऊपर नीचे नहीं रख रहा। कहाँ रख रहा हूँ? सिर्फ अगल बगल अरेंज कर रहा हूँ। तो अगर हम इस अरेंजमेंट को ध्यान से देखेंगे तो दिस अरेंजमेंट, if I just arrange the particles along the direction of length and then the direction of breadth, I will get a seat kind of objects or not? Yeah, basically I will get which kind of objects? A seat kind of objects, isn't it? So if I get these seat kind of object when we are arranging in two direction at the same instant of time, क्या इस पार्टिकल को जैसे पकड़ा, इस पार्टिकल को अपन ने कंसिडर किया है ना, तो उसी इंस्टेंट पे ध्यान से देखना कि वहां पे उसके दो पार्टिकल, एक इधर आ रहे हैं, एक इधर आ रहे हैं, तो एक सेम टाइम पे दो पार्टिकल की अरेंजमेंट हो रही है या नहीं हो रही? फिर इस पार्टिकल को पकड़ा तो इसके लिए एक और ये है कि नहीं? तो बेसिकली वी आर अरेंजिंग इन टू डायरेक्शन एट द सेम इंस्टेंट ऑफ टाइम, then we get another kind of geometrical object, a geometrical object which is two dimensional in nature। which kind of nature? और इस टू डायमेंशनल ऑब्जेक्ट्स को ध्यान में देखो तो ये ऑब्जेक्ट सिर्फ सरफेस पे लाई कर रहा है ना, वॉल्यूम पे लाई कर रहा है क्या? नहीं ना। तो इसलिए इसका नाम पड़ा सरफेस काइंड ऑफ ऑब्जेक्ट। सरफेस काइंड ऑफ ऑब्जेक्ट, है ना। अब मान लो अगर अपन ने पार्टिकल्स को पकड़ा और तीनों डायरेक्शन में अरेंज कर दिया, मतलब लेंथ, ब्रेड्थ और हाइट, तीनों हाँ, 3D जैसा, मतलब लेंथ पे भी एक्सिस है, ब्रेथ पे भी एक्सिस है, और साथ में एक्सिस जो है वो कहाँ पे है, हाइट पे भी है। तो ये जो ऑब्जेक्ट्स इसमें से जनरेट होंगे उसका नाम क्या है, 3 डायमेंशनल ऑब्जेक्ट्स, या फिर वॉल्यूम ऑब्जेक्ट्स, क्या बोलते हैं इसे अपन। मेरी बात समझ में आ रही है। तो basically if I arrange the particles, how many kinds of particles we have, 1, 2 and 3. One is called as linear, based upon the arrangement of particle. A geometrical figure can be of anything, but based upon the arrangement of particle, how many kinds of objects we get, one dimensional, two dimensional and three dimensional. One dimensional means only along the direction of a rod, means only in the direction of one dimension. Yeah, and if I have two-dimensional objects, then I'll have the length also, breadth also, means the particle will be arranged along the length, along the breadth. While in three-dimensional case, it will be just in the case of all the directions, length, breadth, and height. Are you able to get me or not? Okay, now if I consider, so first one example of this is we usually give is a straight rod, isn't it? But the if I look into another arrangement, basically I can turn these arrangements and I'll still have one contact, and the particles are only arranged in one uniform direction only. If I consider one particle for it, there is only one particle in front of it. Are you able to get me or not? So from this, I'll get a ring over here or not. So basically a ring, if you can also think like, if I just bend a straight rod, it will bring a ring out of it, isn't it? So ring is also example of which kind of object, one dimensional object. क्या होगा ये? Yes, is that clear or not? अगर हम टू डायमेंशनल ऑब्जेक्ट्स के बारे में बात करें, अगर इनकी हम एग्जांपल को कंसिडर करें, तो एक तो हो जाएगा तुम्हारा डिस्क हो गया, है ना, या फिर रेक्टेंगुलर सीट्स हो गया, या स्क्वायर सीट्स हो गया, है ना। यस, मतलब जो भी प्लेनर फॉर्म में है, एनी सिमेट्रिकल प्लेनर फॉर्म, दिस इंप्लाइज एनी सिमेट्रिकल प्लेनर ऑब्जेक्ट्स, है ना, आर गोइंग टू बी माय टू डायमेंशनल ऑब्जेक्ट। कैसा होगा, टू डायमेंशन। बट थिंक ऑफ अ हॉलो स्फीयर और अ हॉलो सिलेंडर, हॉलो स्फीयर और हॉलो cylinder. Think of that. What will happen then? Basically, these are my 3D hollow objects or not? These are three-dimensional object. Yes. Inside is like hollow. But although they are 3D hollow objects, try to think of one thing. If I just cut a sphere, I'll get a proper plain sheet of paper or not? If I cut a hollow cylinder, I'll get a proper plain sheet of paper or not? So basically, although their representation, their appearance is 3D, but due to their particle arrangements, their particle arrangement is not 3D kind of thing. It is basically which kind of thing? Two-dimensional kind of thing. Are you able to get me or not? Okay, so we will consider the 3D, every 3D hollow objects, since their arrangement, if we, the arrangement is planar basically, like hollow cuboid, hollow cube, hollow cone. So all these are, if you cut them, they will become a plain sheet of things, right or not? So that's why we are going to consider every 3D hollow object as two-dimensional object. Which kind of object? Is this clear or not? मजा आया? अब देखो, अब 3D hollow, 3D ऑब्जेक्ट्स क्या हो सकते हैं, तो इसका तो एग्जांपल फिक्स है, जो भी अपना 3D सॉलिड ऑब्जेक्ट होगा, हाँ, 3D सॉलिड सिमेट्रिकल ऑब्जेक्ट्स, ठीक है। तो these are examples of three-dimensional objects, means they comprises of length, breadth and height. While if I just consider 3D hollow objects, I have to just consider in case of, if I just see the mass thing, I'll just consider the area kind of thing. Are you able to get me or not? So basically this I am distributing on the basis of mass arrangement, means matter arrangement. Are you able to get me? Okay. Now, as the arrangement of matter is different, as the way of representation of each and every matter is different, basically, if we get to see these things like one dimensional, two dimensional in a much more concrete way, then how we can imagine them? That's the biggest question. Okay. So, how we will imagine? Let us consider 1D, 2D, 3D. So first of all, we need to define one quantity which we call it as volume. क्या चीज define करना चाहते हैं हम? अच्छा, अब ध्यान से सोचा जाए तो कोई तुमसे पूछे कि वॉल्यूम का डेफिनेशन बताओ तो क्या बताओगे? What is volume? It is the space occupied by the matter. Correct. So basically every volume is a space occupied by matter. बहुत लोग ये नहीं बोलते, बहुत लोग क्या बोलेंगे? It is something the space, length, breadth, height, and all. Yes, so they will tell these kind of things. Okay, but the point is simple that we will not say regarding that. We will try to understand what is actually a space occupied by matter. Any space which is occupied by matter is called as volume. Are you able to get me or not? So if I see one dimensional object, the arrangement is just linear, isn't it? In 2D objects, the arrangement is kind of surface. In 3D objects, it's kind of volume. Are you able to get me or not? So now if I just consider the consideration of linear objects, अगर मैं क्या consider करूँ, तो हमारे पास कुछ ना कुछ डेंसिटी का फॉर्मूला होना चाहिए. डेंसिटी बराबर क्या होता है? मास बाई वॉल्यूम होता है ना. तो फॉर linear object the volume, if I see the arrangement of particles, they are only arranged in which way? Linear way na. So the volume will be taken as L. Are you able to get me or not? So remember that volume, उस दिन भी मैंने बताया था, volume of rod. If I say, since the arrangement of the particle is linear, so volume of the rod will be given as length. Are you able to get me or not? So we tell that density is equal to mass by how much? Length. For which kind of object? One dimensional object. And then we call this density as a special name. We provide it, we call it as linear. So we denote linear mass density by a special quantity called as lambda. कैसे से डिनोट करते हैं? लैम्डा. लैम्डा बराबर व्हाट क्या होता है? मास बाय लेंथ. क्या क्या होता है? लैम्डा इज इक्वल टू मास बाय length. Now, if I consider 2D objects, I have the surface. So once again, I'll have the density is equal to what? Mass by volume. But if I just consider volume, in case of surface object, the volume, the matter is occupied by only surface areas or yes. So that is called as surface. So here volume takes the place of surface area. And then we call this density as no, surface mass. Yeah, okay, that is also correct. Surface mass density or area mass density. Okay. And it is denoted by what? Sigma. कैसे से denote करते हैं? And sigma is given as mass by surface area. Which area? Are you able to get me? And for 3D objects, no need. We have density is equal to just mass by volume. और we call this, इसका डिनोशन कैसे से करते हैं? रो से. इसका तो कोई दिक्कत ही नहीं है, मास बाई वॉल्यूम ही रहेगा एज इट इज, है ना, 3D में. और इसका नाम होता है वॉल्यूम मास डेंसिटी. क्या बोलते हैं इसको? आर यू एबल टू गेट मी? Now, why we are aware of all these kind of things in a much more great sense, but let us first of all understand what is called as density. Then I will get the essence of these things. Is that clear or not? So, if someone asks you, can what you will describe of density? What is density basically? Tell me. Okay. Density is number of per unit volume. That's the correct. So basically, density is not related with mass. Mass is just a representation. Can we say like that? We can't say that because every density formula goes through mass. Are you able to get me? So mass, it's not independent of mass. Mass is just a representation of what we are going to talk about, density. Is that clear? Yeah, it is indirectly related. Are you able to get me? So basically, density is the count of number of means amount of particles, amount of number of particles per unit volume, per unit volume. Are you able? Amount basically amount means or the mass of total number of particles per unit volume. You can say like that. Is that clear? जैसे मान लो ध्यान से सोचो जैसे ये पूरा एक मैंने एक रेक्टेंगुलर प्लेट कंसीडर किया इस तरह का एक रेक्टेंगुलर प्लेट बना दिया है ना जिसकी इसकी एज लेंथ जो है वो कितने के बराबर है ए के बराबर है कितने के बराबर और इस साइड भी कितनी लेंथ है ए ही है तो हम समझ रहे हैं मान लो स्क्वायर है दोनों तरफ एज लेंथ की वैल्यू कितनी है ए हाउ मच इज दैट okay now if I just consider that the whole rectangular sheet was made up of let's suppose 80 particles पूरा का पूरा rectangular sheet कितने कितने particles से बना हुआ था 80 particles are you able to get me or not so basically if I see 80 particles each की mass कितनी है m each की mass कितनी है m तो ध्यान से देखो अपन कंसिडर कर रहे हैं अच्छे से मान लो अपन के पास एक स्क्वायर प्लेट है ना ठीक इस स्क्वायर प्लेट के 4 पार्ट्स हैं डिवाइडेड एंड द लेंथ ऑफ ईच साइड बेसिकली a yeah okay and the mass of each particle yeah is how much is small are you able to get me or not and there are such 80 particles which are present how many particles are present basically how many are present 80 okay now if you see one thing in each part if this is 80 basically that means 20 particles are over here 20 particles are over here 20 particles are over here and 20 particles are over here isn't it how many particles are there 20 20 20 and 20 now if I want to define density so we here it is a square plate so which kind of density I will have surface mass density so I'll have sigma, which we call it as surface mass density, and that will be exactly equal to what? Mass by surface area. यही होगा तो देखो अगर मान लो 80 पार्टिकल से बना हुआ है तो पूरा का पूरा हम स्क्वायर प्लेट का निकाल रहे हैं डेंसिटी कितना निकलेगा टोटल पार्टिकल्स कितना है 80 सबकी मास कितनी है m और सबका एज लेंथ कितना है a तो 80 m by a स्क्वायर आएगा या नहीं आएगा so basically that will be how much 80 m by a square. Are you able to get me? Now let us take one example as we know that from here to here this length and from here to here this length is how much a by 2 and a by 2 isn't it? So I want to find the density of this region now. I call it as let's suppose A, B, C and point D. Is that clear? B, C, and D. So if I define the sigma, once again ABCD is a square means planar surface. So I'll define the sigma of ABCD because it is a planar surface. तो हमें क्या यूज करना होगा सिग्मा यूज करना होगा क्या यूज करना होगा हाँ तो बेसिकली सिग्मा 20 m divided by whole square. तो ध्यान से देखो, it is also 80m by a square or not? So basically what you found that the whole square plate density actually matches with the another a symmetrical distribution is square plate density or not? So basically this is what the meaning of density is. Density says that if I have any kind of object, okay, and the distribution of particle is uniform. कैसा है distribution? There can be a non-uniform also, no problem with that. Okay, that will be, there will be density, but that will be called as variable density. Yeah, this is a constant density. So when I have any kind of object and if the distribution of particle is uniform, then yeah, so then for the whatever will be the density of the bigger part, I mean, बोला, whatever will be the density of the bigger part, a smaller symmetrical part. कैसा part? Yes. So density of, or any part, basically density of big surface will be exactly equal to density of any कटेड पार्ट. आर यू एबल टू गेट मी और नॉट? मतलब अगर मान लो मैंने ऐसा छोटा सा भी एलिमेंट ले लिया ना, तो इसकी भी डेंसिटी कैसी होगी, इसकी जो डेंसिटी आएगी वो एग्जैक्टली डेंसिटी ऑफ स्क्वायर के साथ मैच करेगी. आर यू एबल टू गेट मी और नॉट? एंड दैट्स द मीनिंग ऑफ डेंसिटी बेसिकली. इज दैट क्लियर? So basically, if I have the density formulas like this way, like lambda, sigma, and rho, which we defined right now. So we have three densities, lambda, sigma, and what? Rho basically. That is lambda, linear mass density, which is mass by length, and then there is sigma, surface mass density, which is mass by surface area. I denote the surface area by just A. क्या जैसे denote कर रहे हैं अपन A, and then I have the sigma, volume mass density, which we denote by rho. That must be equal to mass by what? Volume. Are you able to get me or not? Then as I know that if I take a rod, let's suppose if I take a rod, okay, and this rod from here to here, if it has mass m and length how much? L. How much is my mass? M, and length how much? L. Then in this, I can even consider a very small element from here to here, which will have some mass m dash and L dash or not. Then also I can even consider in this a very other too much very small element or not, which has mass how much? Dm, and length how much? Dx. Are you able to get me or not? Then the concept, if it is a uniform object, कैसा है ये ऑब्जेक्ट? अगर ये यूनिफॉर्म डेंसिटी का ऑब्जेक्ट, अगर यूनिफॉर्म डेंसिटी है, तो लैम्डा की जो वैल्यू होगी वो बड़ा मास बाय बड़ा लेंथ के लिए जो होगा, वह भी मेरा छोटे मास बाय छोटे लेंथ के लिए भी होगा, और वो भी मेरा सबसे छोटे मास बाय सबसे छोटे लेंथ के लिए होगा. आर एबल टू गेट मी और नॉट? तो किसी तरह का भी मैं कटिंग करूं, सबके लिए डेंसिटी कैसी रहेगी? सेम. कैसी रहेगी? बराबर. इज दैट क्लियर और नॉट? मेरी बात समझ में आ रही है, नहीं आ रही? मजा आया? ठीक है. तो we'll move ahead with this, and then now we define sigma, which we call it as mass by surface area, isn't it? Density. So let us suppose if we have any kind of, sorry, we are not taking unsymmetrical parts, we're only considering symmetrical objects. I forgot that. So let's suppose there is a square plate. Okay. because I have drawn it in such a way that it can be visible. And then let's suppose this length is uh, B, and this length is basically A. Is that clear? Then whatever will be the particular sigma, we as we know that it is, if it is a uniform density, and we can even consider a small square plate over here or not, which have mass m dash and a smallest area a dash. But in this also I can have a very small element which will have mass dm, और इसकी सबसे छोटी एरिया बेसिकली dA लिखेंगे, dx dy नहीं लिखेंगे, क्या लिखेंगे, dA. Are you able to get me or not? So then we define sigma as total mass, बड़ा mass by बड़ा area is equal to छोटा mass by छोटा area is equal to सबसे छोटा mass by सबसे छोटा area if it is uniform. कैसा हो बेटा ये? Uniform हो. Is this clear or not? मेरी बात समझ में आ रही है? अब सेम अगर मान लो 3D ऑब्जेक्ट है, किस तरह के ऑब्जेक्ट, ठीक है, तो वन सेकेंड, अगर मान लो बड़ा मास है तो बड़ा मास का एक बड़ा वॉल्यूम होगा, है ना? सिमिलरली छोटा मास का एक छोटा वॉल्यूम होगा. अगर ये 3D ऑब्जेक्ट भी कैसा है, यूनिफॉर्म है, तो रो की वैल्यू क्या आएगी, बड़ा मास बाय बड़ा वॉल्यूम इज इक्वल टू छोटा मास बाय इज इक्वल टू सबसे छोटा मास बाय सबसे छोटा वॉल्यूम. And that's how we cut the objects. Are you able to get me or not? Understood? Is that clear or not? That's not all. Let us see something. So let us consider one rod. Let us consider one rod. Okay. Which has mass m and length how much? L. Mass is how much? M. And length is how much? L. Then I want you to tell me that what will be the mass in the region from from L by 3 to L by 6. Tell me. Hmm. बताओ. बताओ क्या होगा. It's how much? M by 6. Let me check. तो बेसिकली अगर मान लो, निकालेंगे कैसे, तो हमें मालूम है कि ये ऑब्जेक्ट कैसा है, हमने कंसिडरेशन डाल लिया. अगर कुछ नहीं दिया हो तो मान लो कैसा है, यूनिफॉर्म. क्या है? तो बेसिकली हम मान लो इस छोटे से पार्ट का जो मास होगा, हमें पता नहीं, हम कैसे निकालेंगे, हमें तो पता नहीं, क्योंकि हम कट कर लेंथ को निकाल सकते हैं। तो अगर ध्यान से देखा जाए तो L/6 to L/3 के बीच में जो लेंथ है वो कितने का है? L/3 माइनस L/6 को कितना आ रहा है? L बाई कितना आ रहा है? L/6। सो हमें मालूम है कि यूनिफॉर्म डेंसिटी है तो लैम्डा बराबर क्या आएगा? मास बाई लेंथ इज इक्वल टू छोटा मास बाई छोटा लेंथ, है कि नहीं? तो मास कितनी है? पहले m थी, अभी लेंथ ऊपर से बड़ी लेंथ l ही थी। अभी मास m डैश हमें निकालना है, लेकिन लेंथ कैसा है अभी? L/6। सो बेसिकली m डैश इज हाउ मच? M/6। इज दैट क्लियर और नॉट? Okay, that's so correct. Now let us consider that if I have a rod and in this rod, नहीं अभी काम आने वाला है। अगर बोला कि ये अभी नॉन यूनिफॉर्म रॉड है, किस तरह का रॉड है? And the density is varying non-uniformly. This is the variation of density with the length. Okay. तो अगर मान लो ये टोटल लेंथ ऑफ द रॉड था L, कितने का था? हाँ, तो पूछा वन सेकेंड, अगर टोटल लेंथ L है तो बताओ व्हाट्स द मास बिटवीन मास प्रेजेंट between L/3 to L/6, sorry, L/6 to L/3। ये क्या है? ये L/6 है, ये क्या है? L/3। if the coordinate is this 0, 0 and the particle lies on the x-axis and the rod lies on x-axis। Think what we have to do. बताओ क्या होगा? So there comes the technique. Now here the mass becomes variable. At each and every point, there the mass is totally different, isn't it? But then we have one concept that whatsoever happens, for any small mass of any small length, lambda still remains same, isn't it? So lambda can be written as सबसे छोटा mass by सबसे छोटा length, isn't it? Because it is a linear object. It is which kind of geometry? Yeah, simple. So basically, we can write dm as we know lambda over here. So lambda into dx or not. And if we integrate it, what we will do? We'll get here mass, and then if we put lambda's value 1 plus 2x into what? dx and take the integration from L by 6 to L by 3, I'll get the net mass present between that region or not. So basically put over there m is equal to, but this comes in terms of length actually. We should actually divide this by a constant number or something like that. So there comes a approach, but we are not, we are ignoring that fact. Okay. So the integration will go through dx L by 6 to L by 3 plus 2 x dx from L by 6 to how much? L by 3. What I will get? Integration of dx is just x from L by 6 to L by 3, और इसका क्या हो जाएगा x square by 2, तो 2 2 cancel, x square from L by 6 to L by 3, that will give me the mass of this region or not. Are you able to get me? But this is in terms of length. Remember that this is what we are calculating. We are calculating mass in terms of length over here. Is that clear? So there will be some constant which will be divided, which will make the length dimensionless, and it will turn it into cases. Are you able to get me or not? If you would have get it the numerical value of length, this mass would have been in actually basically kc. Are you able to get me? Okay. Viva. It's like a constant case because lambda is represented as kg per meter per year. Are you able to get me? So when you will just multiply with meter, meter gets cancelled, and I will be left with kg or not. Here it is what? Kg by meter into meter. Meter gets cancelled. I live with kg. But here I'm not putting the constant value of length. We are just taking a variable length. That's why we might think that this mass is in terms of length, but that is not correct. Actually, it is in terms of kT. Put a numerical value of length here. That's the mass in kg. Is that clear? Are you able to get me? Can you move ahead? So basically, we are going to use, you keep in your mind all these things. We'll learn much more these things. We are going to utilize this many times. Okay. So this graph, this drawing, you should take as a picture and put it on a wall also. That this is going to be the required framework of many things in this whole series of mechanics. Are you able to get me or not? It also helps. It is also going to help into electrostats of class 12 and everywhere. Everywhere this is going to be same, and this is going to help you. Okay. Okay, so this process will be utilized everywhere. The things will little bit vary, but then once again we'll get the same thing. Okay, now let us come to our main task. We were on work energy power. We defined different cases of work, and we calculated the same thing using for the rod relation. So you can prefer this lecture. You can revise this lecture with the help of that notes which I have given right now, and you will get the answers. Is that clear? Same thing is over here, and we defined our reference point for measuring patterns potential energy. If I measure it upwards, it's positive. If I measure down, it's negative. Is that clear? Yeah, according to which system? It's not Cartesian system, it's just our system. No, it's not Cartesian even. Okay, it's just a reference which we are making. Okay, Cartesian system is. Hmm. Hmm. Okay. So we'll jump on to our conclusion, and then we'll move and see the term called as kinetic energy, first of all. Isn't it? Basically, I'll not take too much time on describing these. So we know that kinetic energy is given as nothing but it's the energy when the body is in motion, and we define kinetic energy as half mv square. The formula of kinetic energy is what? Next point is, as we know that momentum is also given as mass into velocity. So we write kinetic energy in terms of momentum as p square by 2. But remember that this kinetic energy is defined for a particular case. That if a body, when a body is on a ground and the body is moving with a constant velocity, ये mass के पास कैसी velocity रहनी चाहिए? Then the kinetic energy will be defined like this way. If it is a variable velocity, if v varies, this implies kinetic energy is different at different instant of time. at different instant of times. Is this clear or not? So based upon this, we will bring one big concept over here, and we call it as something called as, oh shit, I think it came in between it. 1 minute. Ah, so we'll call it as something called as work energy theorem. Right now we just gave the work for the which kind of force? Conservative forces. But today we will see what is called as actual theorem of work and energy. Now let us devise one experiment. We have a surface, and then on it there is a cart. What is there? Okay. And then I have this perfect cart over here, my Lamborghini Gallardo, and it is going to run. It has some acceleration a naught in forward direction. In which direction? And then I have a block of mass m attached with the spring over here. Is that clear? With some F external pulling it up. And this card surface is also rough in nature. कैसा है बेटा? कैसा है? Rough. Wow. You might see, what the hell, sir? Why you are bringing so many forces and everything over here? That's a big question or not? But let us see. Let us just see. If we see the number of forces on this mass m, we'll draw that. Let us just draw that. So this is my mass m, isn't it? So the first force is F external upwards. Okay. Second thing is its weight, gravitational force downwards, isn't it? Gravity, which we call it as what? Mg. The block has always a tendency to go down, so the frictional force acts upwards, isn't it? And of course, I'm just going to draw. Wait. So there is a pseudo force also, ma naught. No problem. And then there is one more force which I call it as normal, isn't it? Yes? From this surface, are you able to get me? All of these forces are doing something and something and something and something, isn't it? So the question arises that how all these forces are going to affect my body, how all these forces are actually going to make us understand what is happening in the body, isn't it? So we'll see that how we define, how we actually create the equation out of that, and then we will move ahead. Is that clear? So the point of relation of all these forces basically brings us into a conclusion that how to relate it. Now, as we see over here, the mass m is in non-inertial frame, isn't it? Non-inertial means accelerating. So pseudo force we have already considered. So we have everything over here: gravity, pseudo, friction, normal, F external. Everything is present over here, isn't it? Now we know that actually, if we see the net forces over here, how many forces are actually working? We have F external, then we have force of gravity, then we have basically force of normal, then we have force of frictional force, देन एक और बच गया, स्यूडो बचा है ना? स्यूडो भी बचा है कि नहीं? बोलो हाँ। इज दिस क्लियर और नॉट? So we have so many forces acting over here on one particle. So we'll write the equation basically. F net is equal to F external. I'll write the short forms. Force of gravity as G only. Then force of normal as F of n. And force of friction as a small f. And force of pseudo as P. Are you able to get me or not? These are the number of forces which are acting on one particle. Yes, we know that if we have any kind of work done on the particle, that will be brought by all these F nets. All this force net will bring the net work done in the body or not. In dot displacement, are you able to get me or not? And one more thing is that when we see that these all the work forces are doing some work on the body, we know that whenever we have F net dot ds, basically written as force is basically written as what? Mass into velocity. Sorry, mass into acceleration. And ds, I'll just replace that ds with dx. Are you able to get me or not? Now, what is basically this quantity? If I write work done, then it is nothing but mass outside acceleration, and this is my acceleration, this is my displacement. So I can write even acceleration in terms of displacement as what? V dv by dx into dx or not. Basically, this dx and dx will get this dx and dx will get cancelled. Now, if I do a work, we know that the particle's velocity will vary from v1 to v2 or not. So basically, if my particles velocities vary from v1 to v2, I can write it as what? M v2. This will come as m v2 square minus how much? v1 square. Are you able to get me or not? This is something called as final kinetic energy minus initial kinetic energy. So basically, if we do any kind of work on a body, if we do what any kind of work on a body, then the work done is given as what? Basically, work change in the kinetic energy if we have n number of forces. Which kind of forces? So work done is equal to change in kinetic energy. Basically, that is going to be my one of the first consideration. Can I get? But this is work done due to all forces or not? All forces in the sense that what is actually happening? There are how many forces? F net vector means what? First will come of F external dot ds plus then it will be force of gravity dot ds plus force of normal dot ds, force of friction dot ds plus force of pseudo dot ds, and that is exactly equal to what? Change in kinetic energy. Are you able to get me or not? So basically these are all are what? These are nothing but this is the work done by external force. This is work done by which force? Gravity. And this is work done by normal plus work done by frictional force plus work done by pseudo force is nothing but what? Change in kinetic energy. Basically, this is my work energy theorem, that work done by all the forces in the nature is just exactly equal to change in kinetic energy. Is that clear or not? So work done by all the forces just change in kinetic energy. And work done by conservative force is what? Change in negative of change in potential energy. Are you? Yes, that's the only difference. So now, if we look into the equation, what we have? Work done due to external plus work done due to gravity plus work done due to normal, work done friction pseudo is equal to change in kinetic energy. ये दोनों है क्या? ग्रेविटी और नॉर्मल। ये दोनों कौन से फोर्स होते हैं? कंजर्वेटिव या नॉन कंजर्वेटिव? ये दोनों कैसे? So basically we know that. So basically what will happen? that work done by gravity plus work done by normal, both work done, because both are conservative force. And as we know that, look over there, the normal is always perpendicular to displacement. कैसा रहेगा हरदम? बॉडी ये ऊपर नीचे ऑसिलेट करेगी ना, तो वर्क नॉर्मल कैसा रहेगा हरदम? परपेंडिकुलर टू डिस्प्लेसमेंट हो सकता है. Will not consider it to be zero, just will consider that that is just exactly equal to negative of change in potential energy. The sum of all the conservative force work done is actually negative of change in potential energy. Are you able to get me? Okay, so that means that is of minus of u final minus u initial. Are you able to get me or not? So basically you got your final equation, that work done, if apart from conservative force other three forces are present, which you have to consider, that external friction या फिर pseudo, यही तीन तुम्हें हमें पढ़ने हैं, हमें drag force वगैरह कुछ नहीं पढ़ना है ना. तो then work done by all these kind of forces is nothing but change in kinetic energy, that is k final minus k initial, and this goes minus, it will become plus u final minus u initial. मतलब work done by all the forces is change in total energy of the work done, sorry, work done by external friction and pseudo forces is nothing but change in the total energy of the body. Is that clear or not? And understood? ऐसा ऐसा कभी क्लास में समझाया था क्या? कभी नहीं ना? मेरी बात समझ में आ रही है अभी? ठीक है. So this is called as work energy theorem due to other forces. ठीक. Learn how to use this and slowly learn how to use this formulas. Are you able to get me? So we have three different kinds of equations. First, if we have conservative force only, then I know that energy is also conserved. So two equations are left with. First is work done, that is negative of change in potential energy, which is minus of u final minus u initial, which is sometimes written as u initial minus u final. Are you able to get me? And as for conservative forces, it is a reversible change. That means energy must remain conserved or not. Which kind of energy? Total energy. So that means kinetic energy final plus potential energy final is equal to kinetic energy initial plus potential energy initial. This means that if I have any other forces apart from conservative force, the energy will not remain conserved. So energy remains conserved only for conservative forces. Which kind of forces? ठीक है, total energy will be different. Okay, it will vary due to reversible nature of conservative forces. Is this clear or not? मेरी बात समझ में आ रही है? मजा आ रहा है क्या? कॉन्सेप्ट क्लियर हो रहा है अभी? और अगर मान लो ऑल अदर फोर्सेस आ गए, अगर मान लो कंजर्वेटिव है, नॉन कंजर्वेटिव है, और इफ एक्सटर्नल फोर्स, स्यूडो फोर्स, ऐसे ऐसे बहुत सारे फोर्सेस हैं, तो वर्क डन बाय ऑल द फोर्सेस इज एग्जैक्टली इक्वल टू जस्ट चेंज इन काइनेटिक एनर्जी. और उस ऑल के अंदर अगर कंजर्वेटिव है, तो वर्क डन बाय सम विल बी एग्जैक्टली इक्वल टू change in kinetic energy minus change in plus change in potential energy. Are you able to get me or not? Means conservative हमने we took out conservative outside. ये चीज किसी को नहीं मालूम रहता है जल्दी, है ना? है कि नहीं? और इसलिए वो लोग बार बार वर्क एनर्जी थ्योरम कैसा अप्लाई करते हैं? गलत अप्लाई करते हैं. मेरी बात समझ में आई या नहीं है? फील आया या नहीं है? आसान है? यस ना? सो This is something which I have the mastery about. Means I feel like I was born with these kind of concepts, work in Theorem and all. Okay, because I can easily apply the concepts and easily rectify the things. Okay, so we'll see much more depthness about this. Let us do something. Let us do some questions regarding that. One of the questions which appears, so I'll not go with easy questions. I'll take you through some of the best questions. I didn't have described spring force till now, but I'll take a time to describe spring force and include with that. Okay. So before that, we'll do one question. There is a rough surface like a hill. Jack and Jill, Jack and Jill and went up the hill, something like that. Okay. Then I place a block over here, a block of mass m. Okay. And I applied some force. This is a rough surface. Which kind of surface is this? A rough with coefficient of friction to be exactly equal to mu. How much is that? Mu. Okay. The question is, should I give you at this stage only? Okay, let me give. If you will not be able to do, then I'll just do it after some time. Okay. So the question is, if the length of this base is L and height of the surface is H. Okay, then find the work done by friction. Find the work done by not friction. Find the work done by capital F, F external. Basically, this is my external force or not. So find the work done by F external when the body reaches maximum height. Find the work done by the friction when the body reaches max. F when the body reaches max height. Hmm. बताओ. It's awesome. Yeah, correct. That's what I will also use. It's a hell awesome question. One of the finest, actually, you can say. This is from? No. It's not even from Mitsubishi. It's from one of the toughest book, which we call it as I read of. Got it? You have heard about it, no? So I'll make you do some of the days we'll sit with the IRADA since you are working very good in a physics. So I'll take you to some pro level. Got it? Because the person sitting with you is a pro guy in physics. You will see that. Yeah, means you will see when I will teach you rotational, it will be out of the box some of the things. Okay. Yeah. So think of this case. अच्छा ये सरफेस कुछ ऊपर नीचे ऐसे ऐसे टेढ़ा मेढ़ा दिख रहा है ना, तो हाँ इसके लिए कुछ करना पड़ेगा क्या इसके साथ? करना तो चाहिए हमें, है कि नहीं? हम देखेंगे कैसे क्या करना है कि नहीं? अच्छा तो मान लेते हैं एक छोटा सा रीजन कंसिडर करते हैं, एक बहुत ही छोटा सा माइन्यूट सा रीजन कंसिडर करते हैं, है ना, यहाँ से लेके यहाँ तक। ठीक। तो अगर माइन्यूट सा रीजन कंसिडर किया तो क्या वो स्ट्रेट बन जाएगा? अगर एक माइन्यूट रीजन कंसिडर किया तो वो एक रीजन कैसा बनेगा? स्ट्रेट रीजन, है कि नहीं? मान लो वहां पे जो एंगल ऑफ इंक्लाइनेशन क्रिएट होगा वो कितना होगा? डी थीटा। कितना क्रिएट होगा? ये वर्टिकल लेंथ dy मान लो और हॉरिजॉन्टल लेंथ मान लो कितनी? dx। ठीक। तो ये जो लेंथ होगा बेसिकली इट विल बी हाइपोटेन्यूज dh, है कि नहीं? यही होगा ना। इसके ऊपर ब्लॉक रखा हुआ है, ब्लॉक की मास कितनी? ये एंगल कितना? डी थीटा, है ना? तो इस oh okay, so let's just erase this. We'll not keep hypotenuse. It's of no use basically. We'll come on that. So this angle is d theta. Basically here the force will be what? What will be my force? Mg sin theta. So yeah, correct. Very good. It will be mg d sin theta. Mg sin d theta. Are you able to get me or not? So basically, if I see the frictional thing, if I just see consider about the friction, this is my mg cos theta. So here the friction, sorry, 1 minute, cos d theta. So here, when I'm considering the body which is going upwards with some kind of force F, the friction acting in the backward direction will be my maximum kinetic friction basically. Are you able to get me or not? So frictional force, basically the frictional force present over here for that a small region will be a very small frictional force or not. So I'll define that as what? Mu into mg. What I'll write? Cos d theta. Are you able to get me or not? Is that clear? Now, if I just define that, let us think of one case. If I just want to find the work done on this just for this length, okay, consider it from here to here means for just this small length, the slightest small length. Can I call this by some variable? Let us call it as dz. क्या बोला रहे इसको? So basically the work done by friction will be what? Work done by friction will be nothing but minus of, since friction is opposite of displacement, so df into distance dz or not. What is df? What? Because it is a very small force, I have to calculate for the bigger length, so that's why we are going to integrate, isn't it? So I'll do what? Minus of mu mg cos d theta into dx. This will be my term or not? And since the angle is 180, yeah. So basically, what I will get? Okay. Sorry. Mu mg cos d theta into dz. Are you able to get me or not? What is cos d theta into dz? What is that? Tell me. हाँ बेसिकली ध्यान से देखो तो कैन आई राइट cos d theta as dx by dz if I look into this triangle. So basically this work done by friction reduces to one of the most easiest term, which is minus integration mu mg cos theta into dz is nothing but dx. Are you able to get me or not? But the dx varies from here to here only, na? Which is how much? Length L. Over here it is 0 and over here it is how much? Length L when the block goes up over here. Are you able to get me or not? So x will be integrated from 0 to L, and what I got as work done by friction mu mgl. So whenever the particle is taken up on the inclined plane, the friction work done by friction is basically mu. Yeah, correct. It will be negative mu mg into the base length L. Are you able to get me or not? Is that clear? Now let us just draw the अब इस ब्लॉक के ऊपर क्या ड्रॉ करो, सारे फोर्सेस ड्रॉ करो। तो ध्यान से देखो तो ब्लॉक के ऊपर है नॉर्मल, दूसरी है mg, तीसरी है फ्रिक्शन, चौथी है एफ एक्सटर्नल। कितने फोर्सेस हैं? कितने फोर्सेस I have included? Why mg? I have already considered mg now. Mg sin theta and mg cos theta are component of mg or not? Those are not এই বাবা ये তুমি কি করছিরা? তুমি কি করছি হ্যাঁ? এটা তো yes. So this is mg. If I take mg cos theta, that's the component of this original force mg or not? Why I will write the component if I have included mg? I'm just considering mg. If I use the vector sign, then only I'll use the component. If I resolve all the forces, then only I'll use the component. Are you able to get me? So this is what I'm just counting the forces. So work done by friction, work done by gravity, work done by normal, and work done by force capital F is equal to change in kinetic energy. That's my relation or not? But at the initial point, what's its velocity? At the maximum height, what's its velocity? So change in kinetic energy from initial point to the highest point is how much? Zero. Basically, it is how much? Zero. बात खत्म, बोल है ना? अब देख, अब ये वर्क डन बाय नॉर्मल कैसा हो जाएगा? once again zero because every time normal is perpendicular on my displacement. Are you able to get me? तो इक्वेशन क्या बचा? वर्क डन बाय फ्रिक्शन प्लस वर्क डन बाय ग्रेविटी प्लस वर्क डन बाय कैपिटल F is equal to how much? Zero. Is that clear or not? अब ध्यान से सोचो जरा, इन तीनों में से जो ग्रेविटी होती है वो कौन सी फोर्स है? कंजर्वेटिव फोर्स। तो इक्वेशन क्या आएगा? वर्क डन बाय फ्रिक्शन प्लस यहाँ पे माइनस ऑफ चेंज इन पोटेंशियल एनर्जी प्लस वर्क डन बाय कैपिटल एफ मस्ट बी इक्वल टू जीरो और नॉट, बिकॉज ग्रेविटी का वर्क डन क्या होता है? माइनस ऑफ चेंज इन पोटेंशियल एनर्जी, isn't it? So if the particle goes from here, so initial potential energy will be zero or not, and final potential energy will be how much? Mgh, because this time the mg is at how much height? H height. Are you able to get me or not? So I'll write it as work done by friction. We have also calculated from, if I displace it particle from there to there, minus plus sorry minus लिख लो इसको, minus of final potential energy is mg into height h, initial was 0, plus work done by external force F is equal to how much? 0. So we got the work done by external force F, that is mg common h plus mu into length L. That's my work done by external force. Is this easy peasy or not? If you learn the way, इज दिस क्लियर? मजा आया? पहली बार इतना हार्ड क्वेश्चन बनाया ना? ठीक है। We will just not have the use of that. Yeah, so we just did that, but we took out the essence of that, right or not? No, if the surface is plane, then you do the derivation. I'll give you the case. So it should be same or what? If you have to check that and tell me tomorrow. If it is an inclined plane, Sunday we'll have the class, no problem. So if we have a block of mass m, okay, and sorry, let me bring it. You think I do not know? I am just a question giver guy. Two cases are there, two different inclined planes. Okay, I will say three questions are there, three different inclined planes. All are rough in one case. Second case. Take. No, I will see that. So this is rough with coefficient of friction how much? Mu. Is that clear? So find the work done by friction. Is that clear or not? If the inclination is theta, height is h, length is l. Mass m, I apply a force F and the surface is still rough with coefficient of friction how much? Mu. Okay. Uh, Once again, inclination theta, height h, length l. Similar to this question, which we did right now. Third case, mass m, I applied the force F, but I am taking the body slowly. Yes. And the surface is rough with coefficient of friction mu, inclination is theta, length L, height h. Okay. So think, do. That's your task. Fine? Correct. अब मजा आएगा है ना? So this will be your homework. Just take this as homework. Try to solve it. Give me the solution. Provide me the solution. I'll check it and verify and then tell it to you. What is the correct answer? Is that clear or not? Till that time, we'll learn one more thing, and that is called as spring force. Work done by spring force. Now, if I consider a spring force, okay, let us just take a block, attach a spring over here with a block of mass m. ठीक है? चलो, इतना दूर कर लिया? ठीक है? So attach a block of mass m. Now, it was at this time natural length. कैसा है ये अभी? नेचुरल है, ठीक है। एट अ मान लो अगर रेफरेंस पॉइंट ये ओरिजिन है तुम्हारा, तो इट वाज प्रेजेंट एट अ डिस्टेंस हाउ मच? x, x naught basically. I call it as how much? X naught. I started displacing this object, is that clear? And brought this object somewhere over here. Is that clear or not? By displacing from the natural length, how much distance? X distance. How much distance? Is that clear? Okay. So sometimes people add it, sometimes since we are measuring from the reference point, I should do the measurement from reference point basically. So this distance will be how much? Actually, I call it as x. This is so basically all the measurements must be done from the reference point or not. So that's why we are considering x. So this gap, the maximum, the expansion is how much? Just x minus x naught. Look at the spring force. Spring force will be in which direction? Backward direction. Yes, so we know that the spring force is given as what? Minus of k. अगर spring constant है k, x minus x naught आएगा ना? Because its expansion is x minus x naught. Are you able to get me or not? Is that clear? Now, if I look at the particular case of spring force, if I just try to understand, and then basically जो स्प्रिंग फोर्स है मैंने उस दिन तुम्हें क्या बताया था स्प्रिंग फोर्स इज अ काइंड ऑफ कंजर्वेटिव फोर्स विच काइंड ऑफ फोर्स now for any kind of conservative force work done by any kind of conservative force is what negative of change in potential energy or not. So basically I can write if I just expand it so negative of change in potential energy which is u final minus what u initial must be exactly equal to what. I'll do the integration of this or not. So what I will get? I will get half of k x minus of x naught whole square, isn't it? Because we know that work done is equal to what? So this will be it will come as I think minus also because already. Okay, so I'll just write this equation. We know that work done is equal to what? F dot dx. Yes. So spring force is how much? Just kx minus of x naught and your displacement is how much dx over there or not, but the angle between displacement and spring force is how much 180, so I'll call it as negative. Are you able to get me? Uh-huh. You got it? Is that clear? So basically I'm treating x minus x naught as one number, so what I will get is just the x case, so what I will get work done as minus of half k x minus of x naught whole square. Is that clear or not? So this is my basically the work done. It is work done by the spring force is basically what? Negative in nature. कैसा है? Because you took the particle little bit farther away, isn't it? So और ध्यान से देखो तो displacement जिस direction में है, जिस direction में originally my displacement is in the direction towards right side, but the friction, the spring force work done is towards left side or not, and due to that only the work done by the spring force is negative. Is that clear? So that is why we can write u final the relation of potential energy of the spring force. We call this as a spring potential energy. क्या बोलते हैं इसे अपन? And that is exactly equal to half k x minus of x naught whole square. And if अगर x is equal to 0 पे सॉरी x नॉट इक्वल टू अगर 0 पे मतलब हमने मीन पोजीशन को मतलब अब हम मेजरमेंट कहां से स्टार्ट कर रहे हैं न्यूट्रल पॉइंट से कहां से सो अगर वहां पे अगर पोटेंशियल की वैल्यू क्या है बेटा 0 है कितनी है 0 तो फाइनली द स्प्रिंग पोटेंशियल एनर्जी इज गिवन एज हाफ k x स्क्वायर इफ x इज माय एक्सपेंशन इज दिस परफेक्टली अंडरस्टूड और नॉट ठीक तो हरदम याद रखना वर्क डन बाय स्प्रिंग फोर्स कैसा होता है नेगेटिव फोर्स बाय स्प्रिंग फोर्स कैसा होता है नेगेटिव कैसा होता है बस बात खत्म इज दिस क्लियर tomorrow we are going to utilize day after tomorrow we are going to utilize this and then we will move ahead. Monday I have a holiday. If you can plan a class by 6 any time at what time 6:30 p.m. Monday. Okay, okay, so we will have on 6:30 p.m. Monday. Is that 6:30 p.m. it can't be possible by 9 p.m. Before that also not possible, 4 p.m. or morning anytime. Oh, okay, 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 okay. 6 p.m. Monday. Okay, then I'll plan that today. Is that clear? Okay, so we'll meet on Monday. कैसा लगा? मजा आया?